We have two plane waves. So one is traveling along x-axis and another along y-axis. So they are given by a cos omega t minus kx and a cos omega t minus ky. We need to find the wave motion of the particles in xy plane if both waves are transverse and their oscillation directions coincide. And second, if they are longitudinal. So first is when the waves are transverse and their oscillation directions coincide. So one wave is traveling along x and one wave is traveling along y, and the waves are transverse. So their oscillations can be anywhere perpendicular to y. This oscillation can also be anywhere perpendicular to x, but they are coinciding. So that only direction where they can coincide is z direction. So now I have plotted the the waves are planar, but I have taken two of the waves that are, one is passing through the x-axis and one is passing through the y-axis. So it's clear what's happening. So as their displacement directions coincide, that direction must be along z-axis. And second, we have shown in the graph displacements due to just two waves that pass through the origin at t is equal to 0. So I'm just going to plot this at t is equal to 0, how the waves will look like in x and y axis. So this is how they will look like. So at t is equal to 0, both the waves in x and y direction, they will reach their maxima. So you can see here, so when you put t is equal to 0, in both of them you will get, and of course at origin, that is x is also 0, y is also 0. So both of them will reach a. So E1 and E2 both will become A. So this is at t is equal to 0 at origin. And after that you have a sine curve at both the sides. But what you can note here is both of them are reaching maxima at the same time. And their wave velocities are also same. So every time they will reach their maximas at the same time. So both are undergoing a constructive interference. So that's what I have shown. So we can observe constructive interference at origin. So this graph has no relevance to the actual answer, but this is just so you get a feel of it, how both waves are transverse and their oscillation directions are coinciding. And at t is equal to 0, what's happening? So now, because we have concluded that both their displacements are in z direction, so because of both the waves, the displacement, let's write them as z1 and z2. So z1 is equal to a cos omega t minus kx. And z2 is equal to a cos omega t minus ky. So final displacement will be z1 plus z2. So if you do that, cos of a plus cos of b, so that will be cos of a plus b by 2 into cos of a minus b by 2. So you can see the time term will not be here. Time term will be only in this. So this term represents the amplitude. So let's write k as 2 pi by lambda, and when we do that, net amplitude comes to be 2a cos pi into y minus x by lambda. So as you vary y and x in xy plane, because that's what we need to know, we need to find the wave motion in the plane xy. So we have found the amplitude in xy plane, so in terms of y and x. Now if amplitude needs to be maximum, this term pi into y minus x by lambda, that should be equal to n pi, so that this whole term becomes plus 1 or minus 1. And when we want destructive interference, then this net amplitude must be 0. So this term pi y minus x by lambda should be 2n plus 1 pi by 2. So here the particle will always be at rest at this loci of y and x, and here the particle will reach the maximum amplitude A max. So if we cancel the pi, we are going to get our equation in y and x. So if you see here, this will be y minus x is equal to n lambda. So wherever this happens, we will have maximum amplitude. And in this equation, you will get y minus x is equal to 2n plus 1 lambda by 2. So where this happens, the particle will be at rest. So origin y and x are 0, So you can see that is n lambda constructive interference. So particle will go reach the maximum amplitude A max. So that we saw in the graph also. But with the equations, we can get other points as well. So wherever y is equal to x, so that is this straight line. So all the particles that are on this straight line, there the amplitude will reach its maximum. So where there the amplitude is maximum. And wherever y minus x is odd multiple of lambda by 2, so that is when this is lambda by 2 at an angle 45, then 3 lambda by 2 at an angle 45. Then if you go here also, y is lambda by 2 at an angle 45. So all these points, the particles at all these points will be at rest. Now he has asked to show the pattern in the plane xy, but this what I have shown. So if you can extend this plane in the z direction. So these lines which I shown are the cross sectional of the planes. So actual planes are outside and inside the plane, inside the xy plane. And this displacement I cannot show it in z direction, but actual displacement will be in z direction. So the motion will not be along in xy plane, but actually, so you can imagine this particle will come up the plane and go down the plane, come up the plane and go down the plane. Particle here at any point on this line, that will be at rest. And in between, the amplitude will be less than A max, but not 0. So that is the answer of the first part, when the waves are transverse and their oscillation directions coincide. Second, let's see what happens when the waves are longitudinal. Alright, so now the waves are longitudinal. So the wave that's traveling in plus x direction, the particle's displacement is also along plus x direction. But I have shown it with our normal waveform. So you can imagine that the particle is here. So the particle's displacement is this much. So this shows the quantity of displacement, but the actual displacement will be along x direction because the waves are longitudinal. Similarly, the one wave will be passing through the y-axis. So there also, at any point if you take on the y-axis, its position will be given by this distance sy. Now again you can see, let's observe the origin. So the particle which is at origin, so these graphs are again at t is equal to 0. So you can see that at x is equal to 0 and t is equal to 0, both will reach their amplitude. So the particle's displacement in x direction is also maximum, and particle's displacement in y direction is also maximum. So again, don't get confused. This yellow line, so this, when I say this yellow line, this point, this shows the displacement of particle in x direction. And this blue dot here will show the displacement of particle in y direction. So even though it looks like it's in x and this yellow is in y, but because these are longitudinal waves, I have no other way to express it. So therefore, Sx is equal to, because the waves are longitudinal, so let's say the displacement of a particle Sx is a cos omega t minus kx I cap, and Sy is a cos omega t minus ky j cap. And we have shown in this graph displacements due to just two waves that pass through the origin at t is equal to 0. Now we can observe constructive interference at O. So you can see both will reach the peak at the same time, with net displacement being ai cap plus aj cap at t is equal to 0. So this is the maximum displacement. So let's say this is the mean position. So maximum displacement is this. So you can imagine it will go to the other side also. And when it goes other side, it will reach this location, minus a comma minus a. And similarly, you can imagine when in x direction, if it reaches the peak. But in, let's say somewhere in x direction it reaches the peak. But in y direction it reaches the trough. That would be this point. So in x direction it will reach the peak, but in y direction it will reach the trough. So that time the particle will be here, and then when it will go to other end, it will be here. So this square represents the displacement of the particle will be within this square region. So at origin, for example, the particle is going from here to here. At some other position, particle will be going from here to here. So this O is not the origin, this O is just the mean position of any particle. So displacement of every particle will be within the shown square. So let's keep this in mind, and now let's solve the problem. So our displacement Sx is this and Sy is this. So delta phase difference between these two. So at any given time t, phase difference delta phi will be omega t minus kx minus omega t minus ky. So t will disappear, you will get k into y minus x. K is 2 pi by lambda, so this becomes 2 pi y minus x by lambda. So this is the phase difference between the displacement in x direction and displacement in y direction. So again you can see at origin, so y and x both will be 0, and you can see delta phi is 0, so that's why there was a constructive interference at origin. So that's what we saw here. But that will occur at other points also where this condition is satisfied. So let's talk about phase difference. So whenever phase difference is 2 and pi, that will be our proper constructive interference, where both will reach the peak at the same time and here also at the same time. So they will go like this. That's what I showed here. So they will reach the position I cap plus aj cap, and then later they will reach minus ai cap minus aj cap after half a time period. So the particle will oscillate in a straight line like this because they are always in the same phase. So if they are in same phase, so let's say this this omega t minus kx is theta. So let's say the phase of Sx, the phase of Sx is omega t minus kx. So let's say that is theta. So when they are in same phase, if Sx is a cos theta, then Sy will also be a cos theta. So that's what happened at origin. That is, Sx is always equal to Sy. That's why it will travel like this. Now second, if the phase difference is 2n plus 1 pi. So in that case, if Sx is a cos theta, then Sy will be a cos theta minus pi, or theta minus 2n plus 1 pi. That will be minus a cos theta. So now you can see when the Sx reaches maximum, when cos theta is 1, so this will become minus 1. So the particle will oscillate like this. So again in a straight line. Third is when phase difference is 2n plus 1 pi by 2. So that time if Sx is a cos theta, then Sy will be a cos theta plus theta minus 2n plus 1 pi by 2. So n is anyway an integer. So plus minus sign doesn't matter. So it is, if it is a cos theta, this will be a sin theta. And if you eliminate theta, you will get Sx square plus Sy square is equal to a square. Particle will be traveling in circle. And any other case, so if Sx is a cos theta, then Sy will be a cos theta minus delta phi. So if you eliminate theta from these, you are going to get an equation of ellipse. That can be like this also, it can be like this also, depends on the value of delta phi. Now let's take all these 4 points, because when we equate this delta phi to any of these 4, we are going to get a relation between y minus x, between y and x. So those loci of points y and x which follow 2 pi y minus x by lambda is equal to 2n pi, whichever points follow that will undergo motion like this. Whichever points follow 2 pi y minus x by lambda is equal to 2n plus 1 pi will follow motion like this. Whichever follow 2 pi y minus x by lambda is equal to 2n plus 1 pi by 2 will undergo a motion of circle. So let's do that. So if we equate 2 pi y minus x by lambda is equal to 2n pi, 2 pi will get cancelled and you will get y minus x is equal to n lambda. Similarly for B, you are going to get this equation. For C, you are going to get this equation. And for the remaining, there will be ellipses. So let's see these three first. So you can see they are straight lines with slope 1 everywhere. So y is equal to x plus n lambda. This is y is equal to x plus 2n plus 1 lambda by 2. This is y is equal to x plus 2n plus 1 lambda by 4. So if you plot that, so this is y is equal to x when n is 0. So wherever this happens, particle will undergo motion like this. Then when y minus x is this, so let's put n is equal to 0. So when y is equal to x plus lambda. So you can see at x equal to 0, that represents this point. So the straight line that's passing through this point. And again, if you put n is equal to minus 1, then you are going to get this line. So that you don't get. So again, okay, I'll explain. So if you put n is equal to 0, you will get this line. If you put n is equal to 1, you are going to get this line. If you put n is equal to minus 1, you are going to get this line. If you put n is equal to minus 2, you are going to get this line, and so on. So at all those points, particle will be traveling in circles. Sorry, this one. This is lambda by 4. Odd multiples of lambda by 4. So that is lambda by 4, 3 lambda by 4. This is odd multiples of lambda by 2. So there the particle will travel like this. So there the motion of the particle will be like this. Finally, at the rest of the places, motion will be elliptical. So between these two, ellipse, between these two also ellipse, between these two also ellipse, and so on. Now the shape of the ellipse, so you can imagine here particle is like moving like this. So if you shift slightly, the ellipse will be like this. It will be elongated like this, like here. And if you move slightly from this position, so on this line, the particle motion is like this. So if you deviate a little bit, the particles will move like this. So left and right of this line, green line, the particle will move like this. Now these arrows, they show the sense of rotation. So how can we arrive at the sense of rotation? So again, this problem is, okay, so what you need to do is, so here we understood. So let's take this line, for example, the passing through the origin. So there it's going the motion like this. There they are in same phase. So let's go a little bit towards right. That is, let's increase x a little bit. So this is our phase difference. So at origin, y is equal to x. So phase difference is 0. Now if you increase x a little bit, and y if you keep still 0, so if you are moving a little bit towards right from origin, right? So y is still 0 and x is a little bit of positive. So you see phase difference comes little bit negative. So if this is angle theta, then this will be theta plus something. Then only this difference will become negative. So again I will explain. We are taking this line that's passing through the origin. So here the particle is moving like this. The phase difference is 0 because y is equal to x. Now if you move a little bit towards right, then y is still 0. X you are increasing a little bit. So this gets a little bit of angle, let's say delta phi, right? And that's negative. That phase difference is negative means this, if this is theta, then this is theta minus phi. Sorry, theta plus phi. So then theta minus theta plus phi will be negative. That will be minus phi. So now you can see that this is some function of t plus phi, and this is that same function of t plus 0. So whatever occurs here will occur a little bit later here. So let's say if you put t is equal to 0, so let's say this whole term is 0, so we are left with phase difference here is 0 and phase difference here is plus phi. So whatever happens now at t is equal to 0, so this will become a cos phi, and here the t has to increase a little bit. So after some time omega t will become phi. So Sx is following Sy in phase. So when Sy reaches its maximum, Sx will reach its maximum a little bit late. So now if you see these two, so one thing is clear that alongside this, the ellipse will be of this form. Now we are only worried about which should be the direction of the motion of the particle. So let's assume it is clockwise. Let's assume. So here Sy reaches its maximum, and little bit later Sx reaches its maximum. That's what I discussed. So this is correct. Now if you go the other way around, then Sx will reach its maximum first and then Sy will reach the maximum. That's not the case. Because if that were the case, then your phase difference will be positive. Your Sx will be ahead of Sy. That's not the case. When you put y is equal to 0 and go a little bit right, then your phase difference is negative, which means Sx is lagging. So Sx is lagging means if Sy reaches its maximum, Sx will reach its maximum little bit late. That's why the direction of the arrow, if you go towards right of origin, will be in clockwise direction. And similarly, if you go other way around, so if you go a little bit to the negative x, so if you go negative x, again y is equal to 0, so phase difference will become positive. So this will become a cos theta plus phi, this will be a cos theta. So when theta is 0, so it will reach its, it will be cos phi, and that it will reach a little bit later. So if Sx reaches its peak first, Sy will reach a little bit later, and that will happen if particles traveling in counterclockwise. So Sx will reach its peak first and Sy will reach little bit later. So if you go towards left, direction will be like this. So that will continue up to here, and then it will again change the reverse the direction once it crosses this green line. All right.